Today we're going to be doing tensile strength testing. Right? You're going to determine the yield strength, the tensile strength, and the type of material of the test material, and that's it right there. All right? You need to conduct the experiment and then turn in a completed lab report next lab, according to the outline that we've laid out. And also have prepared individually a PowerPoint where you can present the results of the lab. It is a combined lab report, both of you, but I want individual PowerPoints for next lab, okay? Now, just as a review, this is a typical engineering stress-strain plot. This is what it should look like as we go through the experiment today. On the y-axis, we have the stress, which again is force over original area. X-axis, we have the strain, which is the final length, the deformed length, minus the original length over the original length. And as you recall, as force is applied, the metal will move through the elastic region to this point, the elastic region being where if the force is removed, the piece will return to its original shape. At the yield point, which should be right here, at the yield point, that will give you your yield strength. Then it goes into the plastic region. The plastic region being, if the force is removed, it will not return to its original form. It's been deformed permanently. The relationship between stress and strain in the elastic region is linear. As soon as it goes into the plastic region, it's nonlinear. We'll reach a max force right here, and that stress at max force will be the tensile strength. So those are the two pieces of information you'll need. You can then go into the table 3 in our text and find out the various yield strength and tensile strengths for metals. And doing that, comparing it to what you find, you'll be able to tell me what type metal this is. All right? Now, the piece will continue to deform. We will not need to add any more force. The piece will continue to deform until it fractures right there. That's what our diagram should look like once we conduct our test. All right? Once again, as it's moving from the tensile strength down to fracture point, it will begin to pull apart noticeably. You'll be able to see it pull apart, and just before it fractures, it'll be called into the necking. It'll necking, which means the circumference, you'll see it get smaller and smaller, and then it'll pull apart. All right? Just a reminder, safety glasses. One of you will take notes, will be the scribe, and the other one will do the testing. All right? Any questions? All right, let's get started then.